All right, cool. So higher order functions, can you build your own? Yes, you can. So we know about the map function. So can anyone tell me about map? It exists in both JavaScript and Python with slightly different, you know, a
Hmm.
slightly different API or interface.
Yeah, it just like takes each element in a list or array, does something to it, and returns a whole new list
Okay,
or
and what is that something that it does?
just whatever function you pass it through.
Yeah, exactly. So we have, let's say, a list. Doesn't always have to be a list, strictly speaking, but basically you can just think of it as a list. So we have a list of things, and we want to transform that list of things into a slightly different list of things. And how do we get that slight difference? Whatever that difference is, you pass in a function. You don't call the function, you just pass in a function and let map call it for each thing and return a new one. So we can pretty easy. So let's just use the built-in one real quick. So we'll just do a list of nums. And we can map over it and we can double these, let's just say. So I can call map, and then in Python, it's just a function that's available in the default scope here. In JavaScript, it's a method on the array object, but um, you know, fundamentally it's doing the same thing. So we need to pass it a function, and we can do this in a couple ways. We could pass in a lambda. So we'll do it the usual way first. So we'll define a function that takes in a number and doubles it. Okay, and then to map, we need to give it we don't call the function, we just pass it the function. So this function is an object. It's a thing. We can pass it in, so doubler, and then we also need to pass in whatever iterator, in this case, a list. Iterator is a slightly more general term, but we can give it a list. And then we call this, and it's going to give us, we're not going to directly get another list for whatever reason. We get this intermediary map object, which we can convert into a list. So JavaScript, you don't have to do this. And then if we print this, actually, let's just do run this, Python, and I get 2468, which is what we would expect. Is there another version of this? So I have a specific, regularly defined named function. I can also pass in a one-off function, basically, which would be a lambda. So can anyone tell me what a lambda is?
It's an anonymous function.
Yep. Cool. Can you tell me anything else about it? Are there any special properties or restrictions?
It can only take one element, right? Or return one.
Yeah. So strictly speaking, a function can only ever return one thing. And a lambda can have multiple parameters. You can have one parameter or multiple parameters. It just so happens that map wants a function that only takes one parameter, but in
Right.
general, with a lambda, you can have multiple parameters. So the other, yeah, thank you. That's good. So the other restriction is that lambdas are only one line. So if you need to do something at all complicated, you can't use a lambda. If you can fit it on one line, then you can use a lambda. And the syntax is a little strange, but the keyword lambda, and then whatever parameter list you have. In this case, we just have one. So this is going to be a number, so I'll just call it n. and then colon, and then whatever you put next has to, in the end, evaluate to a specific value that you then implicitly return. So in this case, we want to double whatever this n is. So we're going to return n times 2. And this should work exactly the same. So why would you do it like this instead of like this? You know, there's never a case where you have to use a lambda. It's just another way to write a function that's sometimes more convenient. But you never have to use a lambda. Okay, so that's the built-in map. Now let's write our own map. And what is the function signature going to be for my map? Assuming we want to basically copy the Python version.
Oh, so this is, you're just talking about basically using a for loop, right? So there'd be nums and then you're just gonna like loop over them.
Well, so I want to write a function that works exactly like map.
Okay. Yeah, so it'd be def my map, and then in the parameter you want to pass would be nums.
Okay, so what parameters does, so when I talk about the function signature, I'm asking what parameters does it take and what does it return?
Oh, a list and a list.
So, okay, so it takes a list and it's going to return a list. I can actually do this. We don't have to do this, but that's fine. So this is the type hint syntax. You don't have to do this, but this says that this function returns a list, and I can actually mark this list. So this is confusing. Just ignore it. But saying this list is a parameter. Are we missing anything? So
it needs to accept a function as well.
Yeah, it needs to take a function because we need to know what to do for each element in this list. So if we follow this, looks like the first parameter is a function and the second parameter is a list. So I can actually do, I can just call it, I'll call it func. And I won't worry about the type hint. I have to import something, so I'm not going to do that. But anyway, so func will be a function that you pass it. And what is the signature of func?
The for loop.
Okay, so we're not worried about how we're going to do this yet. So we have to pass in a function to my map. So what is the signature of that function that we have to pass in? What does it take in as a parameter or parameters, and what does it return?
Takes in a number and returns one.
Yeah, exactly. So in this case, we're talking about numbers, but it takes in a thing, an x, takes in anything and returns a thing, right? So that's the signature. It takes one parameter and it returns something. So how could we implement this? Well, we know we have to return a list. So there are a few ways we can implement this. We'll do it a couple ways. One is using, like, let's say a more traditional or a more traditional version would be that we create an array and we loop over stuff and then we return that array. So I'll call modified list for I don't know what the elements of this is going to be, so I'll just call it elem. It's not a great name, but it has to be general enough. So for elem in list, and what am I going to do now?
Double it.
Okay. Well, I don't necessarily know that it's going to be doubled. So this func could be anything.
Oh, so you'd
Whatever manipulation you want to do.
so
Okay.
you
Called func.
Say that again?
Call the function?
Exactly. We have to call the function. Whatever this is, we don't know what it is. The example above is doubler, but that's completely arbitrary. This function could be anything. So we need to get modified element. This is actually not really modified, it's a new element, but okay. And then we're gonna call func, whatever that function is, and we're gonna pass it what?
The element.
Yeah. And then what are we gonna do?
You're gonna append it to the list, to the modified list.
Okay, so modified list dot append modified element. Okay, and then we know we need to return a list, so return modified list. All right, so let's run this and see what happens. So we need to pass in a function. So I'll go ahead and do the same thing here. I'll pass in doubler. And then I also need a list, in this case, nums. And what output am I expecting now?
The new list.
Right. So in this case, if I give it this specific function in this specific list, what am I expecting to see in the terminal?
Same thing that you've got 2, 4, 6, 8.
Yes, exactly.
Double.
Okay, so let's see if that's what we get. So we do. So this is an example of a higher order function. In this case, it takes a function, but we could also write one that returns a function or both. Yeah, so it's the exact same, it's basically the exact same thing. There's a couple different ways we could implement the interior of this function. So let's, for the sake of fun, let's use a list comprehension. So this is a for loop. We create a new list, we iterate over it, we call the function for each thing, we append it, and then we return the list. So that's fine. It's a little tedious, it's a little micromanagey. Anyone have any ideas for what we can do with the list comprehension?
You could just return num times 2.
Okay, so num times 2. So again, we're on the inside of this my map, so we don't really know what this function is going to be. So we don't
I
know.
guess it could just be like element then. Element.
Okay, so so let me do it this way first. So lm for lm in list. What is, if I call this now, what am I expecting to see in the terminal?
I think it should just return 1, 2, 3, 4.
Okay, good.
Mhm.
Yeah, so that's what I would expect. 1, 2, 3, 4. So why does it just return 1, 2, 3, 4?
Because you're not calling the function.
Yeah, because we're not really doing anything. We're just basically creating a copy of the list, right? It would just be like iterating over the list and appending that to a new list and then returning the new list. So all we're doing here is we're creating a new list, which is part of what map needs to do, right? So it returns a new list, which is great. But we're missing something. So what are we missing?
The function call.
Yeah. So where do we do that?
For the first element, call it and put the element in the function call.
Yep. So the first thing that you have here in the list comprehension, this is going to be, this represents each new individual element in the list. So what we want is to return this modified thing. So we're going to modify it here. So now if we call this, we should get 2, 4, 6, 8. Again, this works the exact same way. you know, depending on your preferences, you might like, it's certainly more concise. Obviously in the beginning, it's, you know, kind of bizarre and unfamiliar, so it's, but yeah, list comprehensions are stuff that you're gonna see in Python for sure. And this is also, just like this version, a higher order function. It takes a function and. All right, any questions about that?
I just have a question, I guess, about map. Why does it return that? I'm not sure what to call it. That like that memory address, or instead
Yeah.
of
Okay, good.
the list itself.
Yeah, so that's an interesting, well, let's take a look at that real quick. You mentioned memory address. Let me comment this out. So let's go back here. And I'm gonna not cast it to a list. So now I have double nums. So I'm calling map directly on this thing. So if this were JavaScript, I would expect to just see a new list, right? But in Python, you get this thing, map object at some hex code thing. So this is kind of baffling. And yes, it's complicated. Like, why do you get this instead of a new list? One answer is that it's a little more flexible, so it's not restricted necessarily to just lists. And if you have this intermediary representation, then you can, you know, you can do other things. Whereas with JavaScript, for example, it's tied. It's a method on the array class, so you can only do it for arrays. But if you want to look, so in general, some Python has really good dynamic introspection, so you can take a look at what things are like while you run the code, which is very cool. So one thing you can do is dir, dir. So you can call dir on this double nums thing. Let me make this a little bigger. And now if I run this, we get a whole bunch of gobbledygook. We have all these dunder, these are called dunder method, double underscore. So dunder, like double underscore something and then double underscore. So all of this, these dunder methods and properties, they basically indicate that these are internal Python things. Like LT, this is actually less than. So when you use like this operator, like, you know, 5, whatever. So 8 is greater than 9, which is going to be false, obviously. But so here we have this, and this is going to evaluate to a Boolean. And because numbers have this LT implementation, so map, we know from looking at the dir that map is comparable. So I can take one map and I can compare it to another. I can say, is this map, you know, equal to this other map, etc. And we'll see this later on. We'll eventually create our own classes, but you can also create your own classes and you can implement these methods so that you can treat your custom objects like normal Python objects. But yeah, so that's the basic idea. If you want to do anything useful with it, basically you just need to make sure you convert it into a list. And we also have this next thing. So next basically makes it an iterator. So you should be able to, let me see. Yeah, it has iter and next. So that means that you can basically loop over it. So even though this map object, it looks like, you know, not anything very useful, you can still map over it, or you can iterate over it. So I can do for, I don't know what this is, x in double nums, print x. And here we get the actual values here. So, we'll get into some of this later. This is, a little bit more advanced. So I'm just saying it for the sake of saying it, but this, like, looping over something or iterating over something, this is basically an API. So if you want to write your own iterable thing, a thing which you can put in a for loop, you can actually do that in Python. So you can, as long as you implement stuff in the way that Python expects you to implement it, then you can do that. And you can create your own iterable classes. Okay. All right, so that's that's the basic idea. Higher order functions. You can create your own. You can also create your own custom classes that implement behavior, like native behavior in Python as well, like being for loopable and stuff like that. Okay. All right, so that was maybe a little bit of a warm up. So today we're going to be talking a little bit about lambdas and list comprehensions, which I already kind of did, but we'll do it indirectly. So if anyone has specific questions, definitely ask me. If you want to take a look at this README, if there's anything that jumps out at you as being unclear, definitely ask me. But I'm kind of, I'd basically like to do something maybe a little more interesting. So one thing is that I noticed, not noticed, but a couple of you over the course of the last week have been asking about, hoisting and things related to how the code is processed. So I thought I would just give a very brief description of how the code you write actually gets processed. So this step is roughly called compilation or interpretation. They're slightly different, but essentially it's the same thing. You're taking your code, whatever you write. So in this case, let's just say we have right. So we write something here. We write it in text, right? So this is it's just a text file. And we have different characters. These are all ASCII characters and blah, blah, blah. So we do this and then we run the file. And then at some point, something happens. But there are actually a set number of steps that occur from this code that you write to what actually gets executed. And those steps are roughly tokenization. And tokenization means I have this raw text and I want to get all the individual elements here. So if this were a string, this were just a string, which really, that is what it is. And I wanted to get all of the tokens. In this case, I could use something like split. So I could do my program. Then I could do something like tokens is my program dot split, and I'll split on spaces. So now we have an array of individual tokens. Now this is obviously a very simple example, but we'll just keep it simple. So you write your program, which is just text, and then the first step is to tokenize it, to grab all the individual elements, all the variable names, all of the operators, all of the keywords, anything like that, and just chunk it up into little bits. And then the next step after that, it's actually going to take all of those tokens and it's going to run it through what's called a parser. And the job of the parser is to take this, flat this flat list of tokens and turn it into a tree. So a tree with like nodes and children and all kinds of things. So you start with this flat list of tokens and you end up with what's called an abstract syntax tree, which is just a tree with all of the code in it. And then there's a couple other steps which we're not going to talk about at all, but one is that tree gets converted into bytecode, which is what the Python interpreter knows about. And then that bytecode also gets in turn translated into machine code, which is what actually gets run on your computer. So there's basically those four steps. So you write your code, then it gets tokenized, then it gets parsed, turned into an abstract syntax tree, then it gets turned into bytecode, and then it gets turned into machine code. So let's take I can draw this out a little bit. Here's if you happen to be interested in this kind of thing, I'll post this link in Slack. Yeah, so this is a nice, if you happen to be interested in that kind of thing, you can walk through that. So I'm gonna kind of diagram this out real quick. So first off, we have this string, which is what? Let's just say total equals 8 plus 2. All right, so I have this is the code that I write, as a human in my code editor. But this is not runnable, right? I can't just give this to my computer and say, execute this. So it's going to go through this process. So first is tokenize. So we'll create some tokens. So first token is total, and then equals, and then 8, and plus some, and 2. All right, so here are my tokens. Be bigger. Let me just make a note of that here. Okay, and then after it's tokenized, we need to create the abstract syntax tree, which is going to be a hierarchical structure. So we turn it from a flat structure to a hierarchical structure. And that's I'm going to copy these. And that's going to look something like this. So we're going to have basically expressions. So expressions are going to evaluate to other things, and there's an order. So first out, we have this assignment operator. So we have an assignment operator, and assignment operator, if you think of it like a function, it's basically a function that takes 2 parameters, right? Because if you use the assignment operator, you have to some value, and then you have to have a variable name. So it's basically like a function that takes a variable name and a value. Okay, and then this expression, this is another sub-expression, which is also like a function, which happens to take 2 parameters, 8 and 2. So if I write an add function, I give it 2 numbers, and it gives me another number. So I can move these down here. And I'm gonna just highlight these to indicate that they're operators and not values. And then we draw some lines. So this is roughly what an abstract syntax tree looks like. So you can start at the top, and if we're not going to talk about this right now, but if anyone is interested in like algorithm stuff, there are different kinds of graph or tree traversal algorithms. There's depth first search and breadth first search. So in this case, what we're doing is we have to go down to the bottom of this tree to actually get something meaningful, right? So we're going to start here. We know this takes 2 terms, and this side has to be evaluated before this side can mean anything, right? It's total can only be of value. And if we give it an expression here, it's not going to know what to do. So we have to turn this expression into a value. That means we go down to this node and we look, okay, it takes this and this. Are these actual values? If the answer is yes, then you can stop there. If it's not, if they're both, if it's like 8 plus 2 plus 3, then you'd have to go down another step here. But in this case, we can stop here. So this expression can be evaluated. This evaluates to 10, and then we have total equals 10, and then we can, evaluate this. So that's the basic idea, and JavaScript has a similar process. So this is why things like hoisting and that happens, because your code, despite what it looks like and how it feels, it doesn't just immediately run. It actually goes through several processing steps before it actually executes your code. So you can do compilers. So JavaScript and Python are scripting languages, so they're not. I mean, they are kind of compiled, but not like really compiled. If you ever work with Java or C++ or something like that, you actually have to go through a separate compilation step. You write your code, and then you do a separate compilation step, and then you execute it. And in that compilation step, the compiler can do all kinds of things. It can try to make your code more efficient. It can warn you about certain like errors or issues with your code and all kinds of things like that. All right, any questions about that? Okay. All right, so what we're going to do now is we're going to do a group exercise. So we'll do a couple iterations, but we're going to do this. What we're going to do is we're going to write our own tokenizer, which is not directly related to code, but it's the same idea. So we're going to write something that takes in a string and then returns a list of tokens. And we're going to actually try to write in imitation of one that already exists in a third-party library. So I'm just going to walk through this real quick just to show you a couple things, and then we'll create groups and work on this. So first, I'm going to clone this. This is available. You go down to the bottom of this README, lecture, group work, tokenizer. I'll take you here. So I'm going to copy this and okay. Okay, so I clone this down. I'm going to cd into tokenizer and then open it with VS Code. Okay. So the first thing we're going to have to do is we're going to use this third-party library called NLTK. This is the Natural Language Toolkit. So this is if you're interested in like, grammar or linguistics or natural language processing using code, applying code to human language, this is something you might want to take a look at. It's got a whole bunch of stuff and utilities in it. So you can take a look at that. But we're going to focus on just one particular thing. So in order to use this in Python, we're going to have to install it. And the best practice when you're installing stuff is to create isolated environments when you install stuff. So you don't just actually I'm already okay. So you do that with them. So you don't need to worry about, we'll talk about this more and you'll do it more, but for now, just follow these instructions. So we're going to create a virtual environment, we'll paste that in. I am not, let me try this. 1 second. So I think I had another version of this somewhere else. Okay, so I'm gonna take this, I'll copy this. And this is gonna create a folder called vend here, which is gonna basically, it's like having a little mini Python environment. It's only local to this project. So I can install stuff, I can do a whole bunch of stuff without affecting the rest of my computer. So we create the virtual environment and we're gonna activate it. Now we can use it. You can see that it's activated. And now once it's activated, then we can install an LTK. So I'm gonna install this third-party library. Okay. So once we have this library installed, we're going to look at the code. So this code is going to do a couple things. So it's just got 3 methods here, or 3 functions. One of them is just a utility to get a text file, so you don't need to worry about that. You can just run it. And then we have the NLTK tokenizer. So this is what you're going to be comparing yourself to. So this is the third-party function right here. And then this is what you're going to write. So you're going to write something that tries to mimic what this does. And we can take a look. Let's see. Yeah, I always have this problem here. Let me see. I don't know why this works sometimes and sometimes it does not. It's magnet. Let's see. Okay, well, you should be able to. I'm never quite sure. Sometimes it works, sometimes it doesn't. But you should be able to click on Alt to see if this will work. Yeah. Click on Alt, and then this will be a hyperlink, and you can go to the code. You can also, if that doesn't work for whatever reason, you can also go directly here in the virtual environment and live, and then this site packages. So there's NLTK. And we can go here. Let's look in the not in the init. Let's see, corpus tokenize. Yeah, so you could yeah, I apologize, I don't know why it's not working, but so you can go here to the tokenized packet. If you have trouble finding it, just let me know. So this is where this third-party method is defined. So word tokenize is right here, and I'm going to go back to this. So we're calling word tokenize, which is right here. So we can actually look at the source code of this third-party library. And there's some explanation as to what it does. You can see it takes 3 parameters. These 2, what kind of parameters are these?
keyword arguments.
Yep, okay. So do you have to pass in values for these?
I think they're optional.
Yeah, yeah. So these have defaults. So you can do this with parameters. You can have a default value for a parameter. So if you don't specifically pass in language or preserve line, it'll just use these defaults. And then here, what do we have here? It's a list comprehension. It's list comprehension, and it's calling some other functions. So you should be able to, there we go. I guess it just took a while. So my computer just, it's very old and it slows down to a crawl, especially when I'm sharing video. But so I'm hovering over this and pressing Alt Option on the Mac. So I can click on this and then I can jump to it. So it will take me to this function, which happens to be in the same file. So if I want to see what sentences does, I can take a look at this. It goes to sent tokenize. And then this one, if I want to see what this does, I can go here, which actually is going to create this thing. So I can go here and there's a method on this called tokenize. So I can also jump there. And you can take a look at this. So don't worry about trying to understand all the details, but this is just something that you can do. So it's not magic. It's just code that someone else wrote that you've downloaded. And you can take a look at this, and you can see that there's actually a type in here. So this returns what?
A list.
Yep, a list of string. Right, so it takes in a string, and then these are actually default parameters, so you don't need to worry about those. But basically, it takes in a string and it returns a list of string. And if you want to know more about this, you can read the source code. You can take a look at it. Don't obsess. Don't worry about every single detail. You can also just, call the function and pass it different things. You can also go in here and let's say, I want to know specifically about, what sent tokenize does. You can also import it directly into your code and call it and see what it does. Okay. All right, so that's basically how you can look around in source code. And the goal here, the ultimate goal here is going to write something which, write something here which, as best you can imitate the output of this. And there are some tests here that you can use. So it's a little quirky, but it's going to start at the 1000th character just to make your life a little easier. So your goal here is to pass as many tests as possible, and you'll have to write more and more tests. So you can see the comparison here is whatever your custom function does, you're comparing the number of tokens that it creates. And if it's within 10 of the NLTK's version, then you pass the test. So it's not exact science, but that's the idea. And then you'd start here, and then you'd add, some more chunk of this text and see if you can do the same thing, and then add more chunk and see if you can do the same thing. So that's the idea. So you'll we'll put you in groups. You'll take a look at the source code, play around with it a little bit, and then you're going to start writing an implementation, and then you'll write tests. And the goal basically is to see who can pass the most tests. All right. So let's take let's take a 5-minute break. I'll create the groups, and then we'll come back in here and we can get started.